Okay, Assalamu alaikum everyone. My name is Dr. Batul Zehra, and today in association with Masters of Medical Knowledge MMK Hub Academy, we are going to study the topic of cholinergic drugs. So let's begin. Next. So first of all, we're going to talk about the muscarinic receptors so that we can easily understand how the drugs which are working on the muscarinic receptors are having their mechanism of action. So over here you can see that we have 5 types of muscarinic receptors, which are basically M1, M2, M3, M4, and M5. Now you can see that we have written excitatory with some receptors and inhibitory with others. So I have produced a very intelligent way to remember these, and let me show you how. Okay, let me draw it over here. This is M. M for muscarinic receptors, right? Now the drugs receptors which will be on not this. Let me make it again. It's actually a bigger M like this. Okay. So 1, 3, 5. And over here we will be having 2 and 4. So now you can see that 1, 3, and 5 are obviously on the height of going. So 1, 3, and 5 will be excitatory receptors. So M1, M3, and M5 will be excitatory. And as you can see, the 2 and 4 are the below ones. So M2 and M4 will be inhibitory, right? So you can remember that what are the types of M receptors which are excitatory and what are the types of receptors which are inhibitory. So it is very easy to see that 1, 3, and 5 will be excitatory and 2 and 4 will be inhibitory. I hope this will help you all to remember. Okay. Now, first of all, we're going to talk about M1, M3, and M5 excitatory ones. M1 is basically located on the CNS, and in CNS, obviously, if it's excitatory, so its action will be CNS excitation. And in gastric parietal cells, it will do the gastric acid secretion. And then M3, which is also excitatory, so it will going to do on vascular endothelium, it will release nitric oxide and leads to vasodilation. And in exocrine glands, it's obviously going to lead to secretion of the glands. And in urinary tract, GIT, bronchial muscles, which all are basically the which are smooth muscles, so it will lead to smooth muscle contraction. Now we talk about M2, which is the inhibitory one. On heart, it acts for cardiac inhibition, which means it will lead to bradycardia. And M4 and M5, these two are the important ones because they are present in the CNS and they are used for memory, arousal, attention, and analgesia. Okay. Okay, now here you can understand the action of muscarinic receptors in detail. Now, first of all, we'll begin with the eye. In eye, we have M3 receptors. What are they doing? They are contracting the circular muscles of iris, and it will also help in near vision. So this phenomenon is known as meiosis. If you remember that in our sympathetic system, the action of mydriasis was happening. And mydriasis is basically pupillodilation and meiosis is pupilloconstriction. So when we are in a relaxed state, we need to do the near vision, and when there is a sympathetic system activation, there will be far vision. So for far vision, we need mydriasis, and for near vision, we need meiosis. So remember M3 for meiosis, and it will also help to decrease the intraocular pressure. In heart, as we have discussed before, M2 is working on the heart rate, so leading to bradycardia, and our endothelium will release nitric oxide, so there will be vasodilation. In lungs, there will be constriction of bronchial smooth muscles, so it will increase the bronchial secretion. Again, M3. M3 is a very important receptor, and if you remember that M3 is the one on the upside, so it will be the activation or excitatory receptor. In GIT, it increases the motility, so it helps in peristalsis for digestion. It also increases the secretion and relaxation of the sphincter. In urinary bladder, it also helps in contraction of muscles and relaxation of the sphincter so that we can urinate. Obviously, you will urinate in the state of relaxation. So in the parasympathetic nervous system. And exocrine glands, it increase sweat, saliva, lacrimal, bronchial, intestinal secretions. So all of these actions are mostly done by M3 receptors, except the M2. All of these are excitatory. M3 is excitatory receptor, and the only inhibitory receptor over here is M2. M2 is present on the heart, and it is decreasing the heart rate. Remember that. Now, nicotinic acetylcholine receptors are classified as N, G, and M types. NN is present in the CNS and adrenal medulla. So in CNS, it will lead to CNS excitation, and in adrenal medulla, which is a gland, it will release adrenaline. In NG receptors are present on the autonomic ganglia, so they are doing the ganglionic transmission. And NM receptors are present on the skeletal muscles, so they are doing the skeletal muscle contraction. So it is very easy to remember them from the mnemonics. N is for nervous system, G is for ganglia, and M for muscles. Now we have the nicotinic actions in skeletal muscles. If the nicotine is releasing in a very low concentration, so there will be a therapeutic dose because it will lead to muscle contraction. But as you all know that more than anything can be harmful, so more or higher concentrations of nicotine can be toxic, and it will lead to persistent depolarization and relaxation. Okay. Now in cis autonomic ganglia, when it will stimulate it, so it will lead to sympathetic and parasympathetic outflow. And there will be also stimulation of adrenal medulla, which will release catecholamines, adrenaline, and noradrenaline. Now, over here you can see that nicotinic receptors are mostly present in the nervous system, hence they can be known as central receptors, and muscarinic receptors are mostly present in the smooth muscles or in the peripheral organs, so you can remember them from the peripheral receptors. Okay. Now here we are comparing and contrasting the nicotinic and muscarinic receptors, as nicotinic receptors are also known as central cholinereceptors, and most important thing over here that they are mostly excitatory. But if you see the muscarinic receptors, you remember that number 2 and number 4 were inhibitory, and number 1, 3, and 5 are excitatory. So they are present in the periphery, so they are known as peripheral receptors, and they're excitatory and inhibitory both. Now, other is the mechanism of action. As we have discussed before, that the nicotinic receptors are 3 types. So, autonomic ganglia. In autonomic ganglia, they have a stimulation of sympathetic and parasympathetic nervous system. In adrenal medulla, there will be release of catecholamines, and in skeletal muscle, it will lead to contraction. And when we talk about the muscarinic one, they are present on all peripheral organs, inhibited by the postganglionic parasympathetic fibers. So as you remember, in heart, there will be bradycardia by M2. In exocrine glands, there will be secretion by M3. And in smooth muscles, there will be contraction by M3 again. So that's all about cholinomimetics. Thank you so much, guys. And if you have any questions regarding today's lecture, so you can text me in the lecture box. Thank you so much.